Now let's look at a different way that a matte can be created using the color of an image. If you imagine that each color primary or each channel of the image were an axis in 3D space, for example, if red were X, green were Y, and blue were Z, if you took the red, green, and blue values of any given pixel, that would allow you to plot them into 3D space. They would land somewhere in this cube. So, for example, a red pixel, a very bright red pixel that was mostly red, would be out along this axis, X. A very blue pixel would be over here, and a very blue-green pixel would be somewhere up here. Once we've plotted out the pixels, we can measure the distance between them. So, for example, if we measured the distance between that red pixel and that blue pixel, they'd be quite far apart from each other. Whereas a red pixel and another red pixel would not be very far apart from each other. We're going to use a green screen here, so let's think more along the lines of green. If we had a very green pixel, which would be mostly the color of the screen, and we measured it to some other color in the frame, for example, a flesh tone, which might be somewhere over here, it's going to be somewhere further away than the other pixels in the screen. So that's the essence of how a 3D keyer works. Let's look at it in practice. We're going to use the expression node again. And we'll put our expression right into the alpha channel. I'm going to copy and paste from my cheat sheet. But this is essentially doing the Pythagorean theorem in 3D, in a 3D coordinate system, comparing the distance between each one of these red, green, and blue channels. This red 1 and red 2 and green 1 and green 2 and blue 1 and blue 2. The big variable is the color of the screen. Now, if you're a programmer, you might notice that I have a variable here that isn't defined anywhere. So let's fix that. Right now we know that red is implicit and the small r and the small g and the small b are implicit, and the expression node knows that, but it doesn't know anything about these big r's, big G and big B. In most programming languages are case sensitive. So that means that a big R is different from a small r. Nuke doesn't see these as being the same letter, which is convenient because it allows us to use the R again, but for our own purposes, which in this case is going to define the color of the screen. So how are we going to do that? Well, we could use the scratch pad and type the value in here by color picking the screen and typing the values in, but that's kind of lame. Let's look at a feature of Nuke that we haven't really looked at yet, which is user knobs. Nuke has an editor that will allow us to build any kind of interface element that it supports in its nodes. So let's build our own color picker. So we'll pick an RGB color knob, and we will call it sColor. This is the name of the variable it creates, and this is the human readable label. So we'll just call this screen color. And we'll leave the minimum and maximum values where they are, because that'll work. Now, as you see, Nuke has created our own little field for us. And we can even edit the name of the user knob tab here. So let's do that and call it something better. We'll call it screen color. There we go. Now we have our own custom tab with our own custom interface. And if we want to pull these values from this field, the variable we'll use is this sColor variable. So let's put this in here. sColor.r will pull the red value from our sColor variable that we've created. And then we can do the same for green and for blue. Okay, so let's test our custom color picker and see how it works. I'm going to look at the, let's pick a color first. There we have a color, and now let's look at the alpha channel. And I'll pick some colors here, and you can see it seems to be working pretty good. It's picking the color, and then that is defining this variable as a fixed variable that can be used in our 3D keyer. And it works, it'll work on any color, which is another cool thing about 3D keyers. So if you wanted to key off any color, you could do that. So let's take what we've learned about user knobs and use that to expand on our screen suppression a little bit. We'll close that and go to our screen suppress. Remember that it wasn't totally satisfying because it made the screen turn kind of blue, but maybe we can put some sliders in there that would help us improve the results so that it could be blended out a little bit, or we could adjust the average between the two. I worked up a little bit of a formula that would allow us to take the average of, instead of just the average of red and blue, we can take the average of red and blue, but a mix, any mix in between. So rather than the average, any mix all the way from completely red all the way to fully blue. So let's copy this over. So I'm cheating again, copying from my cheat sheet, but in essence what this is doing, we've got to make a couple of user knobs here, and we're modifying our red and blue variables to be adjusted by sliders. So let's make those sliders. First I'm going to define these variables here, and then we'll make a slider. We need to make a slider called RB mix, and we need to make a slider called amount. Let's go to the user tab, and we'll just manage user knobs. We'll make a slider called amount, a floating point slider. And that'll go from 0 to 1, or nothing to 100%. So our D-spill amount, and we'll make another floating point slider that we'll call RB mix. And this one will go from -1 to 1. So now when we slide this slider all the way over to -1, we're in red. And then when we slide it all the way to +1, we're in blue. And in the expression, the extra little bit of expression logic that I added here was just to make sure that the fader mixes that way. I basically renormalized the total slider here so that it's mixing one red all the way to red when it's here, and blue all the way to blue when it's there. And it's all just using regular arithmetic to achieve that goal. And then in the expression here, rather than putting in multiplying it by 0.5 to split the average in half, I'm blending out the entire result. This is where I do the math between the two to get the min. I create those mixes here using these expressions, and then add them together to create the min. And then I mix out the total amount using these amount sliders. So let's see if it works. Right now I got my D-spill amount turned all the way to 0. I'll turn it up. It seems to work. That was our original result. And now when I go this way, I'm saying use the maximum between red and green to D-spill. And here I'm saying use the average of both red and blue, and only let the average of red and blue be the maximum that you allow the screen to get. And then when I go this way, I'm saying I'm controlling the screen more by blue, which you'll see unfortunately has the effect of making them faces feel more red because I'm sucking some of the blue, some of the green out of their faces when I do this. Full blue balance is not very good because of what it does to their skin tones. But having control over the two, we can really fine-tune how much green we pull out without maybe pulling too much out and starting to make their skin tones look ruddy like that, which is not great. And if we want to fade back in a little green, we can even do that. So let's touch up our matte a little bit and slap it over. So here's our raw matte from our 3D keyer. We're just going to grade it only the alpha, and we'll use the white balance, or the white point and the black point, to just adjust this to into a usable matte from the raw matte. And I'm not going to push this too far because normally we would either level the screen or we would use a core matte to fill in this core, but I'm just doing a quick and dirty job here. And we'll do the same thing where we copy. In this case, because I haven't touched any of the RGB values, I could even simplify my logic here and put my suppress right there. And then I could take this whole thing and do a matte merge to put it over here. And we will transform the background over a little bit. Make the bounding box the size of A. Do a crop reformat. And we have all this rigging here as well that we need to get rid of. So the easiest way to get rid of all of this rigging would be to use another roto shape like this. And we could put all of this stuff, this is the shape I created, which is just the junk. So if we wanted to get rid of all that junk, if we put all the things we wanted to keep outside this matte, so this is everything we want to keep, if we put it outside of this matte, we will then have a pretty nice result there. So we're building this comp up little by little. So that's a 3D keyer and user knobs, and a little bit about combining roto with mattes.